All right, so if you also have out your 5-1 sheet, I'm going to just reuse those examples. We're just going to build off that today. Today we're going to look at finding the mean, variance, and standard deviations for our probability distributions that you were introduced to yesterday. And then we're also going to visit the idea of expectation. So the first 3 topics, we're going to build off our examples from yesterday. Then the last topic, we're just going to do a couple new ones just to introduce you to that idea. Then we'll get you some time to work. All right, so for example 1, this is the same example 1 from yesterday, so I'm not just dreaming this stuff up. It says, example 1 said, construct a probability distribution for tossing 2 coins. Let x represent the number of heads. The question is, what will the mean number of heads be? That's the question. I'm going to go ahead, I'm going to put that distribution back up here. You have it on your sheet. So number of heads was our x. And then our P of x, which is our probability. The number of heads we could get 0, 1, or 2. The probabilities that match, we had a fourth, a half, and a fourth. If you want to rejot that down there, you sure can. It is in your example 1 already from yesterday. Same example. So to find the mean for a probability distribution is found by, and I've got the step-by-step there for you, multiply each outcome by its corresponding or its matching probability, if you like the word matching better, and then find the sum of the products in step 1. So to be honest, finding the mean, it's a very simple process. It can just get to be time consuming. It's a pretty simple process. To symbolize our mean, we're using all the outcomes. So we're going to revisit that symbol, mu. Now it sounds like a noise a cat would make versus what a variable should be called. But we're going to revisit, it's that Greek letter mu. It stands for our population mean. We used x bar a lot in chapter 3 because in chapter 3 we used a sample quite a bit. We're using everything in that probability distribution. So population mean symbol is more appropriate because we're using everything in that distribution. So here's what the step-by-step means. Multiply each possible outcome by its corresponding probability. So my first outcome is 0. Its corresponding probability is 1/4. It says to find the sum. I'm just going to put the 2 steps right into 1. Let's make this as least amount of work as possible. Second possible outcome is a 1. The probability of that 1 is a half. Our next possible outcome is 2. Its corresponding, aka matching probability, is a 4th. I do a little plugging and chugging in my calculator. Just put it in parentheses and all. If you want to use 0.25 because that's a nice decimal, only use decimals though if they are those nice terminating decimals. Don't round things. Put the fractions in there. We all have that technology. You're not having to do these things by hand. Put the parentheses in, put the fractions in, and this comes out to be 1. So when tossing 2 coins, the mean amount, or the average, would be 1 head. On average, we would get 1 head when we toss 2 coins. That's all we have to do to find the mean. If you need the formula piece, if you look on that next kind of right-hand piece for you guys, if you need the formula, I already just left it on there for you. The formula you will have, I'll give you a formula sheet just like I have for the last couple tests. That formula will be on there. So if you just take a minute just to interpret it, the capital X's, those are just our outcomes. So in this case, how many heads we had. And then the capital P and then the parentheses, we're used to that probability notation from last chapter. That's just the probability that outcome happens. So that formula will be on your sheet. The step-by-step will not be. So if it's something that you want to practice with, have that formula out when you do your practice. The rounding rule piece, just bringing that back, it's something we did see in chapter 3. I did leave this blank on your sheet for a reason, because I know it's something that I get asked about a lot. So I'm hoping that you see it, you're going to hear me say it, and you're going to write it. So I'm hoping it sticks a little better. We're going to round to one more decimal place than whatever our outcomes are. And then if you do happen to have fractions, if your calculator is able to switch it back to a fraction, write them in lowest terms, or simplify if you like that word better than lowest terms. That's entirely up to you. So that is our rounding rule for those pieces. That's our rounding rule. And that's going to be the case. We're going to talk about standard deviation and variance also. The rounding rules are going to stay the same. The rounding rules are going to stay the same. The reason why we got away from those in our probability unit last chapter is because to go to one more decimal place, sometimes that was a 0 because our probabilities were really small sometimes. So just be careful with that. So let's go ahead. I want to make sure we hit home this idea of how to find that mean. So the example 2 and 3, you guys did the probability distributions and the graphs for these yesterday. So what we're going to do is just find the mean. I'm not going to recopy down that probability distribution because there were 12 different outcomes. I'm not going to recopy it down. So I'm using example 2 from 5.1. If you need to refer to that distribution, you can pull that sheet out if you need, if you haven't done so. Get used to the symbol. It is a mu. It's just kind of a goofy looking M. My first outcome, we're looking at the sum of 2 dice. What was our first outcome in that distribution? A 2. What's the probability that we get that 2? 1/36. The next outcome was a 3. Now it's up to you. I know we simplified those fractions yesterday. Maybe you left yours out of 36. I know in the video piece I simplified them. So the probability that we get a 3 was, what does it simplify down to? 1/18th, right? Now if you want to put 2 out of 36, you can, because we're just going to do this computation and get that final answer. So when you're finding the mean, I don't care if your probabilities, I don't care if you simplify them, you're just putting that in the calculator. So our next outcome was a 4, and we had a 1/12 on that. Then we had a 5, be a 9th. We had a 6, and that one we couldn't simplify, that was 5/36. Then we had 7, was at 1/6. And then we start going back down. It's kind of nice that things end up being a little bit symmetric here. So once we roll to 8, we end up back at 5/36. Then for 9, we're at 1/9. For 10, we're at a 12th. 11, we're at an 18th. And for 12, we are back to 1 out of 36. Now, I did this ahead of time if you want to save kind of that plugging and chugging piece. It's more of the, I don't doubt you guys can enter those things in your calculators. It's more of the setup piece that we really need to take a look at. I don't doubt you guys can all enter on your calculators. We've entered far more complicated things in there, that's for sure. This does come out to be 7. If you want to type it all in, you can. If you want to take my word for it and just write 7, that's cool. As long as you have the setup there, the setup's going to be the big piece that you're going to want as that resource when you try to practice yourself. Okay. Let's go ahead and do the same thing for example 3. We had our car is rented per day for a 60-day period. And we actually don't need to really redo our distribution much. We've got our numbers there. So go ahead, if you need to refer back to your example 3 from yesterday, you can. I'm going to go ahead and give you guys a chance to find that mean for number 3. If you need to look at example 3 from yesterday for your probabilities, you sure can. Otherwise, if you want to refigure them real quick, all the values are right there on this sheet for you as well. So try it out. See what you come up with. I'm going to freeze my screen up here, and I'm going to jot mine down, and we're going to see if we match. If you don't want to simplify your fractions, if you want to leave it like 10 out of 60, you sure can. Or 15 out of 60, you can. So try it out. In a minute, I'll unfreeze my screen. Just make sure you guys have a chance. Again, if you don't want to simplify, like the probability for 0 cars is 10 out of 60. If you want to leave 10 out of 60, that's okay. I ask that you simplify your final answer. What you simplify along the way is totally up to you. What you simplify along the way is up to you. Totally up to you. All right, I know I have a lot of people that are still just entering things in the calculator. So I'm going to go ahead. I'm going to unfreeze my screen so you can check yours. I'm sorry, where did you type in? Oh, yeah. Get that out of there.
Golly, how's 5/3 to the thirds? Yeah, I got 1.
Oh, sorry, 1 in.
I was like, what the heck?
Hang on, I put my 1 and my 2 in the wrong spot. Time out. Here we go.
I was so confused.
It's okay. Little dyslexia shining through for me there. It happens. As a math teacher, it's not cool. I always transpose numbers. I never do it with letters, so I don't know. All right, so now that we have that fixed, I got my 1 and the 2 in the right spots now. I can do basic math, promise. Here's the question I always get, though. Aside from the fact of, hey, Miss Golly, you didn't simplify right. Hey, we got that fixed. Now, the question I always get is, wait, Miss Golly, how can I have 1 2/3 of a car? Our first 2 we did worked out perfect. 1 heads, a sum of 7. It worked out perfect. Remember, we're finding a mean. In chapter 3, how often did it work out that when you found X bar, you got a perfect number like 7? Very rarely, right? It's going to be the same thing here. This is on average, the average amount of cars rented per day for that 60-day period was 1 2/3. That's the average. Same as if we found any other average in chapter 3. Same as if we found any other average. It's not always going to work out perfect. It's not always going to work out perfect. More often than not, it won't, just like we saw in chapter 3. This is still a mean. It's still a measure of average. Okay? So it's not needing to be taken literally, like I can't rent 1 2/3 cars, so the answer doesn't make sense. It's just the average number of cars. It's just the average number of cars. It all is all it is. Now, taking up kind of to the next level a little bit, but not too much more complicated, I'll be very honest. The variance. I've got the step-by-step, and then I also do have the formula on your sheet. The step-by-step will be yours to fill in. Finding the variance is not much more complicated than the mean. And I do, again, want to expose you to the formulas because the formulas will be what you have on your test to use, not the step-by-step. So when you're doing your practice problems, try to start looking at that formula and really making that connection between the steps and the notation. I like the wording, the step-by-step, because I know a lot of us, we're still just getting used to some of those symbols we're seeing in those formulas. All right, so we're going to multiply the square of each outcome by its corresponding probability. And yes, I would underline or put a box around. I would do something in my notes to really emphasize that square word. Multiply the square of each outcome by its corresponding probability. Add everything together. If you need to, if that word sum, again, if that's still kind of getting you a little bit, put a little plus by it if you need to. I know we talked a lot about sums. Well, with our dice a lot last chapter with our probabilities. We did the sum of 2 dice quite a bit. And then we also, the chapter before that, we talked about the sum quite a bit also in analyzing our data. So, but if it's still bothering you, put the little plus. And pour step number 3. Step number 3 of this is the most forgotten thing on chapter 5 test. It's going to be part of the formula. I'll throw the formulas up here so you guys can see it. But for some reason, it is the most forgotten thing on chapter 5 test. I give you the formulas. It's part of the formula. But I don't know if people just don't like me or what it is. But we leave it off all the time. You have to subtract the square of the mean from the sum that you found in your step number 2. And it's shown here in the formula. It's that subtracting mu squared. It's there. It's there. So make sure, again, as you do your practice, I really, really encourage you, have those formulas out. The step-by-step, we're going to do a few of these. The step-by-step, guys, they're not tough. It's not a tough formula to use. But if you don't have the step-by-step in front of you and you just have the formula, can you interpret the formula? That's what we really have to stop and ask ourselves is, can we interpret that formula? We have that capital sigma telling us that it's the sum. We see that we're squaring. And this is our probability. So all the pieces are there. All of those things we are familiar with. It's all symbols we've seen. We worked a lot with sigma in chapter 3. A lot with sigmas. We can't forget to square our outcomes. And then we can't forget to subtract. This is our mean, remember. This is our mean. It's our mean squared. So in order to find the variance, you have to find your mean first. I know it's not part of the steps, but we need our mean first. We do. So if you want to throw that little note in there, you sure can. You do need to find your mean before you can find variance. Standard deviations. Just like in chapter 3, guys, just take the square root of your variance. Don't make it any more complicated than it needs to be. Excuse me. Let's try this out. I'm going to use the same examples we've been doing. I'm not going to deviate from those. We're pretty familiar with those 3. So let's check it out. I want to do example 1 together. I want to give you guys a chance to turn loose on examples 2 and 3. So example 1, I'm just going to relabel it here so we know where to refer to. We're flipping 2 coins. That's the one we're referring to. I know we didn't use this notation in chapter 4. It was chapter 3. I know that was a few weeks ago. We're looking at the variance. Again, I know variance for us in chapter 3, we use the little s squared a lot because we worked with sample data a lot in chapter 3. Now with this unit, I'm using every single outcome possible. So now we're dealing with population. Now we need that little sigma squared. It looks like a little O with a little tail off the side, or a little side ponytail. And we square it. Variance is that symbol squared, our little sigma squared. Our first possible outcome was a 0. We square it. I realize 0 squared is 0, but I want to go through the complete process, no shortcuts. Its corresponding, aka matching probability, was 1/4. My second possible outcome was a 1. I square it. I know 1 squared is 1, but I want to go through that complete process, no shortcuts. The probability we flipped 1 heads was a half. My last possible outcome is that we get 2 heads. We have to square it. Its probability is a 4th. The thing I really want to emphasize here is what is being squared. Just the outcome. The probabilities are not being squared. I'm going to go ahead, I'm going to throw some brackets around that just so we can match it up with the formula piece. There's that first part of the formula. I have to subtract our mean squared. This is the mean that we found for example 1. We found mu equals 1. That is the part. Guarantee, promise. Anything else from chapter 5? I always see a few mistakes here and there. This is the most forgotten thing, is subtracting the mean squared. I don't know what else to do about it besides super emphasize it and hope that you do a lot of the practice so you've got it and don't forget it, and that you use the formula on the test. I don't know what else to do. I do want to give you guys some time though. Oh, hang on, let's go ahead. Sorry, do the computation piece. It ends up with a half. And then I almost totally forgot standard deviation. Probably because it's so simple. Take the square root. If I take the square root of sigma squared, that just gives me sigma. So it's the square root of a half. And that doesn't work out so pretty, so I'm going to use my rounding rule. It says go to 1 more decimal place value than my outcomes. My outcomes are the 1, 2, and 3. Those are all whole numbers. So I'm going to go to the nearest tenth. So we have our variance. Standard deviation, don't make it any more work than it needs to be. Take the square root, move on in life. Okay? All right, so let's go ahead. The sum of 2 dice, that one's going to take a while. So you know what, guys? Let's save a little time today. Let's go to example 3. That's the car rental. Go ahead, take a couple minutes. That's the car rental stuff. Use your sheet from 5-1. The examples are there. Use your sheet from 5-1 so you don't have to keep kind of trying to flip and see the other side of the sheet. Find your find your variance first, then find your standard deviation. Give you a couple minutes here, then I'll start putting some stuff up. Again, we're looking at the car rental data. Everything should be on your sheet from 5-1. Or maybe you just remember them because we just did them. Or if you want to keep flipping your sheet over, you can. Or you can get out 5-1 that has it. It's kind of up to you. Now I'm going to go ahead. I'm just going to put the final answer up here. And if you're struggling to get that, let me know. So I want to make sure you're trying it out. I'm not going to put the setup up. If you're struggling to get that, let me know. I'll come around. I'll double check your setup. And the mean, let me just write that back up here. The mean was 5/3 for that example. We just found that just a few minutes ago. The mean is 5/3. The mean is 5/3. Don't forget to subtract it. Don't forget to square it before you subtract it. This would be a great opportunity to throw those things in your calculator, especially if you've just been writing down, let me do the computation, which is fine. But now would be a great opportunity to practice entering that in yourself. Especially with all those fractions, all those squares. let me move this so you guys can actually see in live here.
No, I think that's just because. That's the average.
There we go.
Oh, but I think even if she did that, it's still.
That is not.
Your mean is at 1
Oh.
Your mean is 5/3 for that one.
Oh, yeah. Okay.
Yeah. See if that fixes. If it doesn't, let me know. And I'll be back. If something's not working out, let me know.
Whatever she uses isn't working.
Oh, that's all I do. I'm running too.
We're at 5:30. I got one more minute. Oh, still. Miss Bella. I messed up.
Wait, how many times?
Every one of them.
I just always go. Try that. So try. I don't know if you don't want to enter the whole thing in again. We can try it again. There might be something else you might have to switch.
So I have my number and then I tried to put 9 in. She tried to put 5, 5, 5. Yeah. Yeah, it said perfect golf and then I can't find my original. And I like clicked off it.
Then if you cleared it though, I can't. I don't know.
I didn't clear it. I tried like going out and I went for no.
Oh.
Yeah,
I don't know. I don't know how to get it back in there.
That's fine.
I put it in the first time and I didn't take back in. Later, you can't see that I'm not in your
And then I messed it up. So
Oh, I thought I was gonna ask if it was Taylor.
Anyway, what did you do?
Taylor. You think Taylor would be telling me I'm like, oh.
Yeah.
I've been all about
Taylor.
Then just leave that in your calculator though.
We don't have one of those.
I don't know why.
We have.
Oh, okay. So what I would do then, if it won't switch, that's okay. Leave it in your calculator. And now go square root. Second x squared. And then go second. Enter to get that answer back.
If you delete that.
Oh, second, sorry. Second negative.
Oh, okay.
And just take the square root right of that. So you don't round anything, just leave it right in there and roll from there.
So question 0. Am I doing this right?
Taylor Girardi.
Yes.
Nice.
Oh, yeah, you're good.
All right, guys, it looks like variance and standard deviation is going okay for us. So let's take a look at our final topic today. And it's not a big leap from what we've been doing. Not a big leap at all. Awesome. All right, so a lot of this is filled in for you on your sheet. It's called expectation, aka expected value. So you might be asked to find the expectation. You might be asked to find the expected value. It's of a discrete. So remember, discrete variables have outcomes we can count. So the number of heads, the sum on 2 dice, the number of cars rented, things that we can count. A random variable of a probability distribution is this part is not on your sheet, it's the theoretical average of the variable. So here's the cool part. Different name, same process as finding our mean for a probability distribution. It's a different name because we're not going to go through, we're not going to create that whole distribution and things like that. It's called our expected value. because if we were to continually if we're playing a game, if we keep flipping our coins, whatever the case may be, in the long run, if we keep rolling our dice and finding the sums, if we keep flipping our coins and counting how many heads, over the long run, if we do that enough, here's what we would expect to have. So if we kept flipping coins, rolling dice, if we were playing a card game, whatever it is, in the long run, we would expect this to be our average, whatever we come out to be. So our expected value is what we would expect to have on average in theory. So the cool thing is it's the same as your theoretical mean. Now I also know we just talked about rounding rules. If problems involve money though, round 2, the nearest cent. Money makes sense to go to the nearest cent, the nearest hundredths. So if you're working with money, don't round things off to the nearest tenths or the nearest thousandths. Go with hundredths. So just make it dollars and cents. Okay. So let's just try a couple of these out. And again, we already know the formula. We've already practiced it. The setup's going to be just a little different. We're going to have to pull some different things out from the setup. All right, so here we go. Let's take a look at example 7. A person selects a card from an ordinary deck of cards. If it's a black card other than a blackjack, she wins $2. If it's a red card between or including 3 and 7, she wins 10. If it's a red face card, she wins 25. If it's a blackjack, she wins $100. Find the expectation of the game. There's the key word right there. All that's telling me to do is find the mean. The expectation just means if I keep playing this game over and over and over and over, how much should I expect to win? So what would my average winnings be? If I kept playing over and over and over, what would I expect? That's why we call it the expectation or the expected value. On average, what would we expect? So we need our first outcome. And here's where I'm talking about setups a little different. When we're flipping coins and looking at the number of heads, the outcome's easy to find. What's my first possible outcome for this game? $2. $2 is my first possible outcome. I know some of you are thinking, no, Miss Golly, your first outcome is a black card. Well, if I try to put black card into my formula and multiply it by something, how's that going to go for us? Not so great. Our outcomes need to be numerical. So my first outcome is $2. What's the probability we're going to win that $2? So we want, I know some of you right now are hating me because you hated the cards things in probability, but they're not going to go away. We have how many black cards? 26 black cards, right? But we don't want black jacks, though. 24. All right. Next possible outcome is what? The $10. Yeah, $10. Okay. Now it says a red card between or including 3 and 7. So we have 3, 4, 5, 6, 7. And we have 2 red suits, right? So 10 out of 52. Next possible outcome, 25. Red face cards. So we have red face cards. There's Jack, Queen, King of hearts, Jack, Queen, King of diamonds, so 6. And last but not least, we can win $100. How many black jacks are in our deck? 2 of them. So if we keep playing this game over and over and over, I'm going to go ahead, just kind of for time's sake here, guys, we would end up with $9.58. Now again, We have to get it out of our brain that our average or expectation needs to actually be like $2 or $10 or $25. It doesn't need to be a whole number. It doesn't have to be one of our outcomes. This is on average. So if I played this game over and over and over and over, and I found the average of my winnings, this is what I would expect. Because not every card wins something. I'm not going to win every time. I'm not going to win every time. Now, why would this game be super appealing? Why would I sit there and play this game all day? You can't really lose, right? Am I going to lose anything? No, there's times where I don't win anything, but I can't lose anything. I don't have to pay to play. Very unusual that you can win money at something and you didn't have to put some money down first. So let's see how that changes things a little bit. We have 1,000 tickets being sold at $1 each for 4 different prizes. What's the expected value if a person purchases 1 ticket? So, and in that first one, guys, I apologize. I should have done the proper notation. I apologize. It should be E of X for expected value. It is the same thing as finding our mean. I got a little carried away on that one. Forgot about our notation. I apologize. Capital E for the expectation. And the setup is going to be pretty much the same as the last one. Let's think about outcomes. What's my first possible outcome? $100. $100, first possible outcome. What's the probability I get that $100? There's 1 out of 1,000. One $100 prize out of 1,000 tickets. Next possible prize, $50. Again, 1 out of those 1,000 tickets will win. Same thing for 25. And same thing for the 10. Now here's the issue. If they were just giving these tickets away, I'd be done. I'd do my computation, be done. But it says I actually purchased a ticket and they cost $1. So in this one I can lose. I can lose my $1. Now here's what we have to think about. I lose my $1 every time. Even if I win the $100 prize, how much have I really won? 99. I lose that $1 every time. So I lose. So I'm going to subtract off that $1. Now it bugs some people just have that 1 sitting there. I literally lose that. All 1,000 ticket buyers, whether they win the prize or not, they lose that $1. So I've really only won 99, or I've only won 49, or 24, or 9. I lose that $1 every time, so we have to subtract that piece off. Again, save a little time. I did the computation on this. And yes, this actually comes out to be negative 82 cents. So if it's a negative, again, what this means is, if I were to participate in this raffle year after year after year after year, on average, I would expect to be in the hole 82 cents. Because if you were to participate in this raffle year after year after year, chances are one of those years you're going to win something, right? Chances are. You might have to play quite a bit. So if you're like, oh yeah, I can live with losing 82 cents, yeah, I'm going to go ahead and throw caution to the wind and buy a ticket. So that's, again, that average. If we did this raffle, participated year after year after year, that is our expected average winnings. One final example with expectation, just showing it in a little bit different light other than playing some kind of game or a raffle, some kind of gambling. It can be also used in investments. This would be a very, very basic use of it, but we're only at a very basic level with this. So it makes sense, we just keep it basic here. All right, so we have a ski resort loses 70 grand per season when it doesn't snow very much, and it makes $250,000 when it does snow a lot. The probability of it snowing at least 75 inches, which would considered a good season is 40%. Find the expectation for profit. So again, this is a simplified version of it, but this is something that an investor would look into figuring out before they say, hey, yeah, I'm going to buy that ski resort. Sounds cool. I want to own a ski resort. They would find the expectation for profit first, though. So, our expectation. What's my first possible outcome? What about the 70,000? It's negative. Why? Because you could lose it. First possible outcome is I lose $70,000. What's the probability that I lose that 70,000 though?
350.
So our 60%, right? 40% chance a good season, 60% chance it's not so great. Remember, we're keeping this basic. There's a lot of in-between seasons. A lot of in-between seasons. And then we have a profit though of 250,000 if we do have a good season. So over the long run, so if I keep this place season after season after season, you would expect to come out ahead $58,000. That would be my average profit over the long run. Over the long run, that would be my expected value. That would be my expected. So again, just a little bit different light, something other than gambling, if you will, something where we can use it in investments also. All right, the assignment piece. Oh, nobody. Ooh. It should already be on your sheet for you. Please make sure you read 5.2. I didn't ask you to, so I don't know why I have that on there. There are calculator steps for this. Kind of take them or leave them. If you want to go through them, you can. I don't think it's a super shortcut, but I mean, you're more than welcome to check those out if you would like.